All right, so next we have our process to solve an exponential equation in general. So to solve a general exponential equation, the goal is to isolate the exponential expression b to the x, or b to any power. And then from there we will take log base b of each side of the equation. By doing that, we're going to cancel out this base of b, leaving us with just our exponent, since log base b is the inverse of b to the x. And then once we do that, the exponential expression will be gone. We'll be able to just solve for our variable, in this case x. So with that in mind, we have an example here of 5 plus 10 to the x plus 1 equals 100. Now this is tempting to rewrite these each with a base of 10 and set the exponents equal, but because of this plus 5, we cannot do that. Instead, we have to use the process we just mentioned of isolating this exponential expression. So we're going to start by subtracting 5 from each side of the equation to isolate this 10 to the x plus 1. And that'll give us 10 to the x plus 1 equals 95. And now that we have our exponential expression completely alone, we can remove this base of 10 by taking log base 10 of each side of the equation. Remember, we just write log base 10 as log. You don't put the 10 there. So we have log of 10 to the x plus 1 equals log of 95. And now log of 10 will cancel out, leaving us with just the exponent of x plus 1 equals log of 95. And now that we've canceled out the base of our exponential expression, we can solve for x by subtracting 1 from each side, giving us x equals log of 95 minus 1. Remember, it's perfectly okay to leave a constant without parentheses around it in a log, but if you feel like you might mix it up, you can always add in these parentheses just to be safe. Next, I want you to take a moment, pause the video, and see if you can solve this problem of 40e to the 2x plus 1 minus 5 equals 115. Okay, so trying this together, if we add 5 to each side, we'll be able to begin isolating this exponential expression of e to the 2x plus 1 that's being multiplied by 40. When we do that, we'll get 40e to the 2x plus 1 is equal to 120. We still need to get this e alone before we can take the log of each side. So we have to divide each side now by 40, which will give us e to the 2x plus 1 is equal to 3. And now we can take the log of each side. Log base e is a special log. We write it as natural log. So we're taking the natural log of each side of the equation. And we want to be sure to write the natural log on the left of each side of the equation, because we're not multiplying by the natural log, but plugging each side of the equation into the natural log, similar to when you have a square root. So the natural log of e will cancel out, giving us 2x plus 1 equals the natural log of 3. Now we solve for x by subtracting 1 from each side, giving us 2x equals natural log of 3 minus 1. And if we divide each side by 2, we can get our x alone, leaving us x equals the natural log of 3 minus 1 over 2. And again, if you are tempted to subtract this 3 and 1, always remember there are technically parentheses around the value inside this natural log. So by order of operations, we cannot subtract before we would evaluate that natural log. So we'll leave it as it is. This is the exact answer, completely simplified.